Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, cycle geometry, we are going to take a theorem number 6 under the cycle geometry. So let's begin. After completing the very lesson today, my dear student, you'll be able to find the image of the angle that appear between a tangent and the radius of a cycle. This is what I hope you'll be able to do after completing the very lesson today. In your favorite segment of the lesson, that is Maths is Fun, today, my dear student, I will explain this interesting number 383 after completing my lesson today, so don't go away. My dear student, to begin the lesson, let us learn another theorem, which is theorem number 6. This theorem is also another vital tool that you can use to solve the problems in cycle geometry. So let us learn the theorem. This theorem says a tangent is a perpendicular to radius at the point of contact. If you have a cycle, remember a tangent is just a straight line touching your cycle at just one point. It is just touching, not to crossing, not to cutting. So you can see this is a cycle center O. And you can see this line AT is a tangent. It is a straight line and it touches this very cycle at this very point. So according to this very theorem, it says the tangent is perpendicular. Perpendicular means meet at angle 90 degrees, which means the angle between the tangent and the radius of the cycle at the point of contact, at the point where the tangent touches the cycle. At that very point, the angle between the two straight lines is always equals to 90 degrees. This is the meaning perpendicular. So from this, I can now write the angle ATO. ATO, look at this very angle. Is the angle at the point of contact where the tangent touches the cycle between the tangent and the radius OT. That very angle is always equals to 90 degrees. And the reason when we make this assumption all the time, what we write is radius perpendicular to tangent. This is another very important tool that you can now use to solve problems in cycle geometry. Let us just move and take examples, and we can now apply this very theorem and answer some cycle problems. So example number 1, it says worked out the marked angles. The marked angles here, it is angle M and angle K. From this drawing, I can see a cycle center O. I can see a tangent TBOBT. This is a tangent because it just touches the cycle at one point. So this is a tangent. And I have angle 37 degrees here. So solution to this very problem. So you now look at the two angles asked to find which one you begin with. It depends the one that you have available information to find. So looking at this angle key, if I can find this very angle inside, look at it. This angle OBC, or rather angle CBO, if I can find this very angle, because line OB is radius and the BT is tangent. So the whole of this angle from this OB to BT is 90 degrees based on the theorem I have just learned. That is radius perpendicular to tangent. So the whole of this angle is now going to be 90 degrees. So if I can find this very angle, I think I am done. I can find the key. So let me just think how I can find this angle. Angle OBC, angle OBC will now be the same thing as 37 degrees because these two angles, 37 and this very angle, look at it, they are base angles of this triangle, and this triangle is an isosceles triangle because two of its sides are radii, OB and OC. So this triangle is an isosceles triangle, and base angles of isosceles triangle are always equal. So this angle OBC is now going to be the same thing as this angle 37 degrees. So let me just write it, and my reason, they are base angles of isosceles triangle. So I have this very angle. So what remains is to find the key like I have explained. O to B is radius, BT is tangent. So the two angles, addition of the two angles together, give the angle between the radius and the tangent. And the theorem says the angle between radius and the tangent, that angle between them is always 90 degrees. So there I can now add the two angles to get 90 degrees. And my reason is it is angle between radius and a tangent, and the theorem tells us that the radius is perpendicular to tangent. So I can now take 37 to the right hand side where it changes to minus. So I have my k equals to 90 minus 37. Subtracting 37 from 90 correctly, you now have 53 degrees. So this angle Q will now be 53 degrees. So what remains is the letter angle M. So let me just move. To find M, you now think, can you find M now directly, or you have to have another angle? If I can find this angle at the center, look at this angle at the center subtended by this minor arc. I can use it to find angle M, my very first theorem. Angle at the center, twice angle at the remaining circumference. And I can get this angle at the center because I can add the three angles in a triangle to get 180. So the addition of the three angles to get this angle B or C, the third angle in a triangle. There I will now have 180 minus 37 minus 37. Subtracting the two angles correctly from 180 give result 106. So the angle at the center is now 106. And the reason is angle at this angle in a triangle. So if I continue, this angle at the center is now 106. And it is this arc that subtend 106 at the center is the same arc also that subtend angle M at the remaining circumference. And the theorem 1 says angle at the center, twice angle at the remaining circumference. So there I can now say my M is now equals to half of 106. That is, you now take the half of the angle at the center, it will give you the angle at the circumference. So half of 106 gives result 53 degrees. And the reason here is angle at the center, twice angle at the circumference. So there letter M, the angle M is now 53 degrees. Let us move and take another example. Example number 2, it says line QR is a tangent to a cycle, and that cycle has a center at O. This is the cycle, so O is the center of the cycle. And look at the line QR, it is a tangent. So the question asked to find is the size of the angle TQR. TQR. It is this angle that is outside. Solution to this very problem, what I'm going to do first is to mark this very angle TQR. Look at the angle TQR. It is this angle that we needed to find. So you now check the information had there given in the question. I have this angle 64 as the angle at the center subtended by arc ST. And that arc ST also subtended this very angle. Look at the angle TQS. This very angle. If I can find it, because O to Q is radius and this Q to R is tangent, so the entire of this angle will be 90. So if I can find this, I think we are done. So let me just find the angle TQS. Angle TQS, this very angle. This very angle is angle subtended by arc ST at the remaining circumference. And this arc ST subtend this angle 64. So theorem number 1 says angle at center, twice angle at the remaining circumference. So I'm going to have my TQS as half of 64. Half of this angle at the center will give result of this angle. And half of 64 will be nothing but 32 degrees. So this angle is now 32 degrees. And addition of 32 degrees and the marked angle will give result 90 because OQ is radius and the QR is tangent. Angle between radius and a tangent is always 90 degrees. So let me just get my marked angle. The angle TQR, the marked angle, will now be equals to 90 minus 32 because the addition of the two angles gives 90. So this one would now be 90 minus 32. And the reason is radius is perpendicular to tangent. Subtracting 32 from 90 correctly, you now have 58 degrees. So this is the angle TQR. Was this I have answered this question. With these few examples, my dear student, I have come to the end of this very lesson. Let me just move quickly to the last segment, Maths is Fun, where I promise to give you the interesting number 383. So 383 is the sum of the very first three-digit palindrome prime numbers. So the very first three-digit number that are palindrome at the same time prime numbers, if you add those three, it gives you 383. So 383 can be obtained when you now add 101 is a prime number. You can see is palindrome. The next palindrome prime number is 131. The next palindrome prime number is 151. If you add these three prime numbers that are palindrome, what you now going to have is 383. We see more of this amazing things in mathematics in our subsequent lessons.